name is Thomas Watson. This is project 1.5, a counting circuit. This project can be broken down into 7 different sections. Each section plays an integral role in the functioning of this full counting circuit. The first section is the analog input. The analog input features a pull-up configuration, meaning that when the button is pressed, it reads low. When this happens, it sends a low signal to both inputs in the first gate of the NAND gate oscillator, causing it to output high. This high signal charges the capacitor located in RC1, which sends a high signal to the second NAND gate in the oscillator for a certain duration. This duration depends on the size of the capacitor. This sets off a chain reaction located in RC2. The chain reaction causes a second input to go high as well. When there are 2 high inputs in a NAND gate, it outputs low. This causes the output of that NAND gate to repeatedly flash from low to high. This low, high patterns are referred to as oscillation, and the signal that it creates is referred to as the clock signal. The 4017 integrated circuit takes the clock signal and converts it into numbers from 0 to 9. It also has a divide by 10 output, which only activates during the sequence. When 0 to 4 have an output from 5 to 9, it does not output. This means that it is only oscillating at 1/10 of the speed of the clock signal, hence its name, the divide by 10 output. The 4510 integrated circuit takes the divide by 10 output from the 4070 and uses it as a clock signal. It converts that signal into binary, which refers to the way the computers understand numbers. This chip has 4 outputs, which means that it can only count the first 4 digits in a binary, 1, 2, 4, and 8. It uses combinations of these numbers to count from 0 to 9. The up-down pin of this circuit changes which direction the circuit counts in. If it is low, it counts high, and if it is high, it counts up as well. If the reset pin is set to high, it resets the count to 0. For normal operations, it should be low. L integrated circuit, the 4511, is responsible for decoding the binary numbers created by the 4510, adds 4 inputs designed for the 4 outputs of each number in binary. Then it takes the binary numbers it receives from the 4510 and splits them up into 7 outputs. Each output is designed for one of the 7 segments on this 7-segment display. These types of displays are one of the most common ways of displaying Arabic numerals in a digital manner. Different combinations of these segments form a legible number, such as 1, 2, 3, etc. 7-segment display used in the circuit is a common cathode display, meaning that all the cathode's negative sides of the LEDs within it are connected. It also means that the 2 center pins are connected to ground rather than the positive rail, as it would be if they were a common anode display, which means all the anodes of the LEDs would be connected. The final breadboard version implements an up-down switch by using the up-down function of the 4510. So as you can see, it's counting up when I have the switch flicked to the right, meaning that it's connected to the positive rail, and it should start the count down when I flick this to down, or DN on the PCB version, which grounds it. The very last step was to solder all these components to a printed circuit board to make a more permanent or organized version of the circuit. This version of the circuit also adds a power switch, which can turn it on and off, and then it restarts at 0. And since the battery is permanently connected, I soldered the lower down components first, like the resistors, capacitors, and the transistor. Then I soldered the IC sockets, which these logic chips go into. After that, we put electrical tape on the solder bits under here and also on the battery, so that because they're so close to each other, they wouldn't short, which would be very bad. Finally, as you can see, I turn it on using the on-off switch. Then I can press the button to begin the counting process. Then if I want to count downwards, like it's doing here, I do that. And if I want to count up, I can simply switch this switch. Thank you very much for watching. Goodbye.